Graphing exponential function. What is an exponential function? A function where the base is a constant, which is the number. The exponent is the independent variable, which is the x. This is an example, y equals 3x. This is the base, which is the function part, which is 3. And this is the exponent, which is the independent variable of that. There are two primary types of exponential functions. They are growth and decay. Growth is a number which is the number of the base that has a larger number than 1. And as you can see right here, y equals 3x, this is a growth because it's larger than 1. And the decay is a base number. The base number has to be between 0 and 1, like this example right here, which is 1/2, which is between 0 and 1, and this would be a decay function. Alright, now how do we graph exponential functions? One, we should graph, we're gonna use this example, and y equals 3x. Push this up. Now you have to make an x and y table, and you can plug any number in. Alright, for this example, for y equals 3x, we are going to use the numbers from the x and y table that we did, the x, any numbers, you can use any numbers with these to plug into them. So when you do that, you are going to get y equals 3 to the power 2 equals 9. Y equals 3 to the power 1 equals 3. Now, this one for y equals 3 to the power of 0 equals 1. And that's because whenever you are going to use the number and use it for the power of 0, it will always come out as 1 no matter what. Now, y equals 3 negative 1. We don't like to use negative exponents, and so how to do this, you are going to put it over 1. This is going to go 1 over 3, and it's negative 1 right there, so it's 1. You're going to do it. And this works because of the reciprocal, and so it shouldn't be negative 1 anymore. Take that away. It should just be a regular 1 because this number, 3, is already over 1. And that's why it's a whole number right there. And so when you do that, you would reciprocate or whatever it, so it could be 1/3 and to the power of 1 instead of the power of negative 1. And since when we switch it, the negative goes away. So that works. Things to remember. Remember anything raised to the power of 0 is always going to be 1. As well as when having sorry, you can't see that. When having anything raised to the power of a negative, use the reciprocal. I really don't know how that's supposed to be spelled. There. And so we're going to put our answers that we got right here. So it's 1/3, 1, 3, and 9. So we are going to graph this right now. So there's 9. So the first one is -1 1/3. And I would say that's about maybe right here, I guess. And then 0, 1, right here. 1, 3, right here. And then 2, 9, that's all the way right here. And so this would be a growth function, like we said up here. And to do this, it's gonna look like that. And it will always keep going up. And this right here will never touch and intersect with the x axis. And that's because that's our horizontal asymptote. And which is, it will never reach right here. So it will never intersect. Oh, there you go. It will never intersect right here. It's growth, and here are all of our things. All right, next example, we're going to do a decay. So it is a decay, just like it's the same. I think it is. Yes. It is different actually, but it is a decay. And so how to do this? I'm going to do the same things. And I'm just going to go from -2, -1, 0, 1, 2. And so now when you do this, you are going to take your numbers again, your extra sheet of paper, and you're going to plug it in. So hopefully you can see this. Y equals 1/3 x. That's our thing. And we will start with 2. One-third squared. So equals, and how you would do that is alright. So right here is our next one, which is the decay graph. And so this time I'm going to use my calculator and just look up the I'm going to look up how to do these and what are the points. So to do that equals, in a second, y, oh, nope. You're just going to y, and then y equals 1/2. Oh. One half. And here it is. This is our table, our graph, and it has all of the points that there would be. So we're just going to go back to the points that we have chose, which are right here. So -2, 4, -1, 2, 0, 1, like always. 1 is 0.5, and 2 is 0.2. Period. Okay, so after that, we can check them off and see if we got them right. So, okay. So these are our numbers, and we can graph them now. So we will go 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. All right. So -2, 4. 1, 2, 3, 4. -2. And then negative. Okay, now that we have gotten our points, we can graph. So I already started, and this point is 2, -2, 4. This one is -1, 2. and 0, 1, 1. And then this one is 1.5, so that would probably be like right here. And then this one would be right there. And as you can see, this is our exponential function as a decay graph. And this one was our growth graph right here. And this was what the growth is going to look like. And here are how the decays are going to look like, going down. Okay. Right here, that's just regular ones. Now we are going to go back and do more of what we have already learned, which is in past lessons, the standard exponential function, which is f of x equals bx, which is just what we just learned, but it was standard. It was like a standard form. And so now we have to change it into f of x equals a times b with an exponent of x minus h plus k. This will represent all of our stretch and compressions, our left to right movements, up and down movements. And to do that, it is, so whenever there's a number between the base number is known as A, stretch or compression. H right here is known for moving the units left and right. And K is to know up and down units. We have to remember that for when we have these, that these are some rules to follow when graphing and their characteristics. So if there's a negative sign in front, right here, so if there's a negative sign right there in front, then the function would be reflected. If A is larger than 1, then the function is stretched. And if it is between 0 and 1, then it is compressed, which is just another way of showing another, like, which also can show growth and decays, because larger than 1, lower than 1. But this is for the base, and this is for A. So two different things, and don't get them mixed up, because they're not the same, but similar. Alright, now, if h is subtracted, then the function moves to the right, that many units. If h is added, then the function moves to the left. So, if h was -2, it would move right 2 units. If you say it was +2, it would be moving left 2 units. But don't let that confuse you for k, because if k is subtracted, then it will actually go down, and if k is added, then it will go up. But these switch signs, and we'll do the opposite. Alright, now how do we graph these? We have to find the characteristics. So I always do that first, and there are 2 characteristics. You are going to move 3 units, and we would move them, wait, what was it? Oh, it's negative, so we'd move them right. And then we would go up 1. There we go. And so now we can just plug in some numbers right here. -2, -1, 0, 1, 2. I usually just use those numbers. This is a growth graph because higher than 1. Base unit is higher than 1. And so now how we're going to do this is I'm going to use my calculator to find the points. So you put it in your y plot right here, your y equals, and then you go second table, and it will show you your points. So we use -1, and that is not the best number, but it's okay. It's going to be 1.03, -1 is 1.06, 0 is 1. One is 1.25, and 2 is 1.5, sorry, my bad, and so good. And so now how we're going to do this, we're going to just plot them again. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 5, 6, 7, okay.
No.
So -2, 1, we're going to put it a little bit higher because that's where it is, right there. -1 is 1.6, so it's going to go a little higher. And then 0, 1 right here. And we'll go to 1, 1.25. Oh, sorry. My bad. So it's going to go again. Like I said, it's going to go down here. So it's -2. Actually, no, it's right here. And then it's right here. And these are really tiny points. I wish I would have picked a different equation. 1.25. So that's like, I'll just go right there. And then 2 is 1.5. Right there. Actually, it would probably be more looking like this. If we're being honest. This is how it would look like. And it is a growth. And it will keep going up as far as it can. Great. So that's next example, our last example. Y equals 3 1/2 x minus 2 plus 3. So what we're going to do is we are going to find the characteristic. So it's going to be stretched by 3 because of this number. And then it's going to move right 2 units. And up 3 units. I'm going to plug it into the calculator. What it is, 3 1/3 times 1/3 exponent x minus 2 and then plus 3. Okay. And then I'm going to put the second. Table. So these are really high because this is going to be a really high number. It's going to multiply to this and stuff, and it's going to be really high. So we're going to choose these numbers. Right here, we're going to go from 2, 3, 4, and 5, and 6. So 2, 3, 4, 5, 6, 2, 6, 3, 4, 4, 3.3, 5 is 3.1, and 6 is 3.0, 3. Okay. So now you're gonna graph these. 1, 2, 3, 4. There's no negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so we're gonna start at 2, 1, 2, and 6. 2 and 6, right there. 2 and 6, 3 and 4. 4 and 3.3, so that's gonna be probably right there. And then 4, 3. Oh, okay. So now this is gonna be this is a decay because less than, it's in between 0 and 1. It's less than 1, higher than 0. And it's gonna decay. It's gonna go down like that, right there. And the horizontal asymptote equals 3. Because it will never go past that 3. Right there. See? There you go. Alright, thank you. This is all that we have covered today in 6.1. That's all I have.